And there's a hand like rusty bread, and in the hand of light. When we take a light, good really walk for all life's time. Hello and welcome to the next day of Advent of Code. Getting ready for the 19th problem to drop here. I guess I'll open up my my Clojure documentation here, so I might need this. Let's see, I'll follow this link and this link. That should be pretty good. 15 seconds, get my windows sort of lined up. I can close Discord here. And yeah, about 5 seconds. Ready in Eclipse, and let's go. Network packet got lost. Starting point. Sometimes the lines cross. Follow a path. It needs to continue and only when there's no other option. Okay. Someone has left letters. Given this diagram, needs to start up here, pass through A, continue on straight to the first plus, then right up, okay, pass through the B. Okay, collect the C. Okay, finally go all the way, following the path to the end. What letters will it see? Oh, okay. All right, so this seems pretty interesting. So how are we going to represent something like this? I think. All right, so we okay. All right, so my guess is. All right, so we've saved this. I think what we want to do is we do want to split this by new lines. And then I think we can just, actually, let me just see if our smart parser function, let's see how it fares on something like this. Okay, looks like it doesn't do too well. So, right, because it's sort of interpreting the spaces. Okay, so all right, let's split this up by new lines. And then I think that's pretty much all we have to do. We could map vector to each of the lines here. Maybe map vec might be even better. Something like this. Okay. Yeah, I think this looks good. So puzzle input lines show the path it needs to take. All right. So I think that we might represent our state as sort of like x, y, dx, dy, and letters here, and along each step of the way. So this we're going to call like board that we're going on, and in terms of the starting state, I think something like well, we can take a quick glance here. So it looks like this is going to start on the 0th row on the 1th column here. So start something like this, and we know that we're going to be headed down. So we'll maybe represent this like this. So increasing y means going down, and an empty group of letters. And yeah, so let's see. So when does it stop? I guess it's gonna stop when there's no more lines to handle here. So each step of the way, I think that maybe we have to like get in the board at, is it XY or YX? It's actually YX. And I think that we need to, I think we got to like look ahead maybe. So based on what we're currently tracking, we need to ask if it's a space, basically. And if it is, then let's see. I think I have a function called adjacents. So if I call adjacents on, like, let's say 3 and 3, okay, maybe I don't. Let me see if it's maybe here. I see. I got something called adjacent squares, so I think I like this one. So for each of these, when adjacent, well, I don't like this very much. I think that pretty much just for an x and a y, I'm just going to emit maybe this minus, and then minus, take just x, add 1 to y, take 1 away from y. All right. So here are our adjacents. So if it's a space, then we pretty much have to let these be the adjacents of our current position. And yeah, we could maybe say for each of these that that they're maybe going to be associated with a dx and a dy. These being, let's see, so something like this, and this, and this, and that, maybe. All right, so we'll call these like xx, yy, ddxx, ddyy. And then maybe like a 4 for these adjacents here when not equal to space, get in the board yyxx. Okay, so in this situation, we'll get the first one of these, and then I guess what we need to emit is the I'll just call this like PV, position and velocity. So just emit this here. Okay, so we get the position velocity out, and then we'll have something called like new letters here, which we'll just define as if maybe like not I. So maybe we can actually let's take the board here and do something like map cat apply concat to board into a set, just to see what the set of characters are that we're working with. Okay. All right, so we can say that pretty much if it isn't one of space plus pipe or minus symbol, then okay, so we're going to let current be this thing here. So get in of just the actual current position. Okay, and then if it is not one of these, then new letters is, okay, add this in. Otherwise, it's just letters as before. Okay. All right, so if we have a space, this handles moving. If we don't have a space, then we just need to add to x dx, add to y dy, leave dx and dy the same, and pass new letters along. All right, so we do something like iterate step, starting here, and take 5 of these. What do we get? Failed to resolve. Okay. Okay. Number ops problem. Let's see. So where are we doing number ops? So we're doing them here, up here, the adjacents to XY. All right, let's get a stack trace. This is saying in an add. Okay. Okay. All right, so dx and dy are, oh, I see. I think I need to redefine adjacents here. Okay, okay. All right. Okay, this is looking good. This says it's just traveling down for a little while. So, and then I need to take these until, let's see, cross over. Someone has left letters, finally all the way and stopping at F. Oh, okay, so something, so I also need to exclude the position where I just came from here. So it must be not the case that xx is equal to, yes, let's see. Yeah, if the place where I can't go and then not equal y. Okay. So all of these need to be true. Okay, and then I think based on this that we can do something like if PV, then return this thing here, and otherwise I think like this kind of thing, and then the way. So I'm going to change this from an iterate to a reduce, operating over like range 100,000, like this many steps here, just to see where we get to, taking some n that doesn't matter. Okay, so this looks like it's stopping at, okay, it's stopping right here. So, all right, so this is saying, well, so this is, well, so it should at least be able to get started here. Maybe, seems like it's getting into this block, but it shouldn't be because it shouldn't be a space. Okay. All right. Get in board 0. Okay, that is, wait a minute. So the X, okay, so this looks better. The X is, yeah, okay. So let's try this. Okay, okay. Yeah, looking much better here. Oh, go 66 down. I don't know about that. Okay. Okay, so this does at least seem to be getting to like maybe um, the first like end point here. Let's just sort of glance at uh, uh-huh, uh-huh. Yeah, okay, so this does seem to be going down for a while, and this is saying it goes down to like 83 here, here. Nope, this should all, here we go. So in this situation, right, you should know that it needs to take a right. So um, so it's got to be the case that the place that we're going. Okay. Hmm. So I don't think I want to take this out because this is what prevents us from going backwards. But so based on our current position, these are the adjacent squares. Look up the board that it is in the space. I don't know. Actually, here, here. Okay, so we call adjacents on 1 and 83. Okay, 2 and 83, okay. Get in board. E3, 2. All right. So I think it should just know that it should just take it. So PV being this, then it should take this next step here. It's actually coming in as nil. Okay. Okay, if we do this, then what happens? Seems like it's getting further, but okay. So actually, I think we don't need, this is actually wrong here. So it isn't that we need to not have our next space be where we are. We need it to be not be where we just came from. So it's got to be the case that we take x and subtract dx, and then we take y and subtract dy. I think this is the actual guard that we need. Okay, there we go. So here's an answer. Okay, Rylon Q. Okay, Rylon. Not the right answer. All right, let's double check this here. Rylonkew. Okay. Well, we can try it with this input here. All right. Something like board 2 based on input 2. Change this. Change this. Doesn't like something there. Did I miss a? Okay. Yep. Missed this. Okay. All right, and different starting position. This seems to be 1, 2, 3, 4, 5, 6 in, so it should start at 5. Okay. And nothing's actually seems to be happening. Um, so, what the? All right. So it seems like, okay. So I think it's getting off the, I think it's getting off the board somehow. I think it's necessary, I think, in adjacent to have something like, uh, something like, um, so yeah, this seems a little bit better. um, yeah, but still not working. So if we try to just take this one step, 2 steps, okay, yep, we got it picking up the A, and 5, 5, 5. Okay, so this should have picked up the B. So let's see, A. Oh no. Yeah, yeah. So okay, oh, 10. Okay, no, 10 doesn't. All right, so 1, 2, 3, 4, 5, 6, 7. Okay, so this goes to 5, 7. Okay, that's not right. It should know that this is. Oh, I see. I think that. Well, it should. Oh, I see. It doesn't know that there's a space there. Yeah. Oops. Okay, so maybe put all these spaces in. Okay. 2. There's AB. Okay, there's A, B, C, D, E, which is good. Uh, but the problem is we change this back to board 2. And this does look like it's. Huh. So this is it. This is a position. Okay, so the Y is this. So if we open this up and go here and go, so it starts at, if it's 0 indexed, then we got to go like this, and then we start at 0 and move 181 over. Then this seems like it should be able to keep going in either direction. It should, so -1. Oh no, there's a space here. Okay. Well, there's a space here, but it should be able to go. Oh no. Okay. So okay, I believe. Okay, so I believe it that this is a terminus. Oh, it's because it picks up the B at the very end. Um, I think. I think that's what it is. Uh, what was it that we guessed here? Rhy lon Q. So in the first case, what changed? Oh, I see, because we were no longer allowed to go off. We were no longer to go off the edges. Okay. Okay, so now lon Q reduced. Okay, so I think it's lon Q followed by a B. LON KEWB. Not the right answer. Okay. I guess. Yeah, okay, so F is part of it. Oh, maybe I just misinterpreted. Yeah, because it should be A, B, C, D, E, F. Okay, so I guess we can change this here to, we could just turn this. All right. LONKEWB. LONKEWB. That's what letters will it see in the order. The routing algorithm is very wide. Make sure you view it without line wrapping. Huh. Um, apply stir. Maybe some kind of string thing that I'm not realizing. NKEWB. Oh, let's see. Let's see what could I be missing if we change these back to board 2. Does it now produce? Does it now produce the right answer? Yes. All right. Okay, let's see. Needs to follow the path till it reaches the end. Sometimes they cross over. It needs to keep going only when there's no other option. Someone's left letters on the line. Then it'll change its direction. All right. Should we get out maybe these again? Okay. So if we turn this filter off, or we just change this to like a filter on identity, then what happens? Same result. All right, so it seems like maybe it doesn't matter that we cancel off the tracks, or rather off the map. Huh. We could I don't know, we could put like a print line in here. Maybe we're missing something. Something like LONKEWB. Okay. We could put in just the current value at any time. This might. Let's see. Can we estimate how many steps this actually takes to run here? I see. Okay. Not done yet. 10,000. 20,000. Okay. All right, so around 13,000 steps. I think that's too many to put in here, but we could use like one of these here, and then we can use like swap bang s conj this. Take 100 from value s. All right, so this says starts on a space. Oh, shoot. That was the mistake. Okay, that's that one. That wasn't too good. All right, here's a new answer. Yeah, there's the right answer. All right, rank 340. Ugh. Yeah, just forgot to reset the starting position. Okay, Packet is curious how many steps it needs to go. For example, so basically it's saying that, wait, steps down, 3 steps right, 4 steps up, 3 steps right. 4 steps up, 3 steps right. 4 steps down, 3 steps right, 2 steps up, 13 steps left. How many steps does the packet need to go? Oh, all right. That's really easy. Um, so um, let's see. So I think actually we want to start with the number 1 because if let's see. So if there was nowhere to go, then it would have gone 0 places. Okay, so we do actually want to start with 0. So we do actually want this number. Not the right answer? What? Huh. Um, well, I imagine it's just off by 1, but um, still pretty surprising. So basically, the first number that gets fed in, the number n, is 0, and if it's the case that there's nowhere to go at that point, then it isn't taking any steps. Saying that you start here and then you go 6 steps down. So 1, 2, 3, 4, 5. Oh, I see. It counts the first step as a step. Okay, so the first step counts. So the answer is 16. Oh, 16. Right answer. Rank 320. Okay. Yeah, pretty frustrating in a couple of ways. So basically, I had the right answer with my first implementation. The only reason that I didn't, that where it had that Rylon Q here, and then the only reason that this wasn't correct is that it ended on a letter and I wasn't handling that case. So that caused me to go back in and reevaluate the test input. And so I did that, and then I found, I found a couple of bugs. I think there was this one here. So this one definitely needed to be fixed. Well, actually, I guess I wonder if I take this out, and what happens? Huh? Nothing good is what happens. So it wasn't necessary to write this part. Then I changed. So basically, I set this up as a different variable, and then changed these 3 instances, 1, 2, 3, of board in my step function. But I didn't change, and I changed my starting state so that things would work. But then I didn't change it back when I switched back to the main problem. So yeah, that cost me minutes. Yeah, pretty bad. Let's see how other folks did. So it looks like they were getting both stars in about 18 minutes. Looks like we took about 30 minutes to get both stars, and the first star about the same. I mean, yeah, it isn't too surprising since the second problem follows pretty easily from the first. Although my use of reduce here and this reduced. So this is actually, I like this idiom here for solving these problems, because basically um, you're in a situation where you want to keep going until something happens, and the part of the program that knows whether you've reached your terminating condition is usually pretty deep inside this step function. So what you can just do is emit a reduced at any given point, and then that'll like halt the computation. Then what you get for free with that is you get to know what step you're on, as long as you just provided a range. And this could be an infinite sequence also, but I didn't need that. I just picked reasonable bounds here. Okay, so so yeah, fun problem. I wish yeah, I wish I'd done a little bit better. I did like this implementation here of the adjacents, where this turned out just not to matter. I mean the filter part. So yeah, basically expressing each adjacent as a tuple of position and velocity. Thought that was pretty good. This this implementation here was pretty bulky. There's yeah, maybe a slightly better way to do it. Maybe yeah. I mean it was fine. It was pretty quick to write. So all right, let's take a look at our advent calendar. Oh my goodness, look at that. Look at it go. All right. So yeah, 6 days left. Really would like to get on that leaderboard, but it's getting more and more evasive. The top 100 is 562 points. I assume that well, some of them are going to continue to get scores. And if I look at my personal stats here, I can see I only got 348 points. So, but I'm gonna try. Gonna keep striving for this. It'd be pretty nice, and it's not over yet. You know, just takes a couple of good days in a row to really make a good recovery there. So you can kind of see. So this was a 100-point day here, and oops, right here, and so you never know. But I'll be back at it tomorrow. Excited to try again, and hope you tune in tomorrow. And in any case, thanks for watching.